chemical equilibrium. Chemical equilibrium. What is a chemical equilibrium as we see here? What is chemical equilibrium? When we take this example of the reaction where A and B react to give C, and the C can also decompose to give the original product A and B. That state is the equilibrium, chemical equilibrium, and this is symbolized with the two arrows, one going to the right, another going to the left. This is the state of equilibrium. But what is the definition of chemical equilibrium? It is a state of dynamic balance where the rate of the forward reaction is equal to the rate of the backward reaction. So the rate of the reaction going to the right is equal to the rate of the reaction going to the left. So this is this state, the dynamic state, where the rate of the forward reaction is equal to the rate of the backward reaction, is a chemical equilibrium. In chemical equilibrium, we cannot learn the chemical equilibrium without mentioning Le Chatelier principle. Le Chatelier. I think he was a French person, a French scientist. And the Chatelier principle says that when a stress is applied to a system at equilibrium, the system will readjust to relieve the stress applied. So I repeat, Le Chatelier principle states that if a stress is applied to a system at equilibrium, the system will readjust to relieve the stress. But what is that stress? Is a physical stress when you have been working all the day and you have a stress? No. Here the stress is the temperature, the stress is the pressure, the stress is the concentration. It could be that you increase the pressure or you reduce the pressure. You increase the temperature or you reduce the temperature. You add more concentration, you increase the concentration of the reactants or of the product, or you reduce them. This is the stress. So I repeat, Le Chatelier principle states that if a stress is applied to a system at equilibrium, the system readjusts to relieve the stress that is applied. This is Le Chatelier principle. And Le Chatelier principle, Le Chatelier predicted also that if we have a gas, this is gas, this is gas, and this is gas, Le Chatelier predicted something where the equilibrium will be shifted when we increase the pressure or we reduce the pressure. Le Chatelier predicts gaseous reaction, the equilibrium will shift to the direction where you have less number of molecules. So the Chatelier, I go to read what the Chatelier predicted. Le Chatelier principle predict that in all gaseous reaction, an increase in pressure will favor the reaction which takes place with reduction in volume. That means toward the side with the smaller number of molecules. Now, look, we have here, at the left-hand side, we have two molecules. We have two molecules. Let me put maybe here, maybe like that. Yeah. Okay, let me put like that. This is gas, right? Okay, I put gas. This is gas. So, one molecule of A react with one molecule of B to give three molecules of C. Now, the Chatelier principle predicts that an increase of pressure in any gaseous reaction, the equilibrium shift toward the direction with less number of molecules. So we have two molecules here, one and one, that make two molecules. At the right-hand side, we have three molecules. So, according to Le Chatelier, if we increase the pressure here, if you increase the pressure, the equilibrium shift to the left, because at the left-hand side, we have only two molecules. But at the right-hand side, we have three molecules. So according to the Chatelier principle, if we increase the pressure here, because it is a gaseous reaction, if we increase the pressure, the equilibrium shifts to the left, producing more A and B. Okay? So this is Le Chatelier principle. Okay? But if we decrease the pressure, we decrease the pressure, then we are going to have more of C. Okay? So this is a very important thing that we need to know when we are learning the chemical equilibrium. And we cannot, as I say, we cannot study chemical equilibrium without mentioning Le Chatelier. But there is also another thing that we need to know here is the Haber process of production of ammonia in industry. Now, we have hydrogen reacting with nitrogen to give ammonia. So we have, if we put two here, and then we put three there. Okay. Now look, we have this. There is here the Haber process. Haber process. Haber Another process is the production of ammonia in industry. In industry, in which condition ammonia is produced? In industry, in which condition ammonia is produced? Look. This is an exothermic reaction. Okay, I go to right, go to like that. And we see that at the here, left-hand side, we have 4 molecules, or 4 moles. 3 moles of hydrogen plus 1 mole of nitrogen. We have a 4 moles. And over there, we have 2 moles. Okay? So now, if we increase the pressure, what are we going to get if we increase the pressure here? If we increase the pressure, according to the Chatelier principle, the equilibrium will shift to the left because we have 4, no. If we, I go to repeat, if we increase the pressure here, look, we have 3 mole and 1 mole, that makes 4, and over there 2. If we increase the pressure, the reaction or the equilibrium shift to the right. Okay? The equilibrium shift to the right. So the pressure, the increase of the pressure will produce more ammonia. Okay? We need high pressure to produce ammonia. In industry, as we see, we need to increase the pressure to get more ammonia. But there is a problem. There is a problem in industry. If you are a manager, you are a production manager, the customers need more ammonia. Now that you say, okay, we need to increase the pressure. We need to increase the pressure, but there is a problem. A problem of safety, because increasing the pressure in the pipe, inside of a pipe of production, there is a risk of explosion of pipes. Okay? There is a risk of explosion of pipes. Safety problem. When there is an explosion in the factory, the people may die. Okay? This is a big problem. Safety problem. Safety problem. There is also economical problem. Economical problem. So, you need money to build and to maintain the factory with high pressure. Okay, you need money to build a factory that operating with high pressure, and you need also money to maintain it. Okay, problem of money, safety problem, economical problem. That is why there is what they say a compromise pressure. The compromise pressure is what? 200 atmosphere. 200 atmosphere is the compromise, is accepted pressure. So I repeat, for a big yield of ammonia in industry using a Haber process, we need to increase the pressure. But as I said, there is risk, safety risk of explosion of pipes and the explosion of the factory. And also, there is economical problem because we need money to build and to maintain the factory operating with high pressure. That is why I say this compromised temperature, pressure is 200 atmosphere. What about the temperature? We have learned in the rate of reaction, the factors that affect the rate of reaction are temperature, concentration, particle size, and so on. Now, this is exothermic reaction. So we need to get more of this, more of ammonia. We need what? We need to lower the temperature. We need to lower the temperature because it is exothermic. Exothermic reaction, that means this side is exothermic, and the other side is endothermic. Okay? Because the reaction is exothermic, releasing heat, if you supply more heat, the system will readjust to relieve that system. That means it has to go the other side. Okay? So if we supply the temperature, more heat, the reaction will shift to the left. Okay? The reaction will shift to the left. That's why we need to lower the temperature. But if we lower the temperature, that means because it is exothermic, if we lower the temperature, the equilibrium will shift to the right, then we are going to produce more ammonia. We need to lower the temperature. But when we lower the temperature, the production will be very slow. The production will be slow. This is another problem. And the people, they say, okay, let's sit and talk. And then they decided to have a compromised temperature. The compromised temperature is 500 degrees Celsius. So compromised temperature is 500 degrees Celsius. Okay, to finish, I'm going to give a summary. So to produce ammonia in industry, so this the production is called Haber process. We know that we have learned that if we increase the pressure in a gaseous reaction, this is gaseous reaction because hydrogen is gas, nitrogen is gas, ammonia is also gas. If we increase the pressure, the equilibrium will shift toward the direction where we have less number of molecules. So when we increase the pressure, we are going to have more ammonia. So we need to increase the pressure to get more ammonia. If you are a production manager, we need to increase the pressure to get more ammonia. But there is a risk, the safety risk, explosion of pipes, explosion of the factory. This is a risk. There is also a problem, economical problem. Money to build and to maintain the factory operating with high pressure. So need money. Okay? So that's why, okay, they say, okay, let's sit and we accept the pressure of 200 atmosphere. What about the temperature? This is exothermic reaction. So to get more ammonia, we need to lower the temperature. If we lower the temperature, then we get ammonia, more ammonia, because this exothermic reaction. If you supply more heat, the reaction will shift to the left. Equilibrium will shift to the left. So we need to lower. If to lower, then we're going to have more ammonia. But another problem, if you lower the temperature, the reaction will be slow. And your customers are waiting for the order, waiting for ammonia. That's why the compromised temperature is 500 degrees. We finish there. Thank you.